Okay, everybody, this is Todd Frazee, and this is the video tutorial for the S60-53 CAD Assembly. So this might be one of your first assembly model projects, and it's critical that when we do our file management that we keep all our files together. So in SolidWorks, an assembly file is really just a file that gives instructions on where to take individual models and assemble them in relationship to each other. Okay, so what we're going to do in this first one is we're going to bring three pieces together and create the primary piston assembly, okay, which is actually a sub-assembly, but SolidWorks doesn't differentiate in its name of the files. So let's look at our drawing real quickly. We've got the S60-53. It's made up of three parts. We have the primary piston rod, the primary piston cap, and the primary piston shell. And if you have not modeled all three of those parts, or you have errors in those parts, you need to fix those before moving on with this tutorial. So the models have to be generated before you can go to this step. We also have a lead-free silver solder. It looks like we're torch brazing the primary piston cap to the shell and then press fitting the rod into the piston cap. So anyway, so you need the solids PRT files for each three of these, and then we're going to create a SolidWorks SLD ASM file. And those four files need to stay together, like I said. Alright, so let's go to SolidWorks. Okay, so we're in SolidWorks and we're going to go to File, New, and we're going to create a new assembly file this time instead of a part file. And it has the part icon with a piece attached to it to denote it. It's an assembly, so it's more than one part together. We'll set OK. And it's going to ask you what is the first component you want to put into this assembly. So if we look at our bill of materials, I'm going to go with the lowest part number. I'll just use the 109. And we're just going to take the default settings. And something in my default settings is the origin's not showing. So I want to show the origin of both the part and the assembly, so they have their own origins. Now for your initial part, I suggest that if you hover over the origin that's in the center of the screen, which would be the assembly origin, it'll align the origin of the first part you bring in to the assembly origin, and then don't worry about the rest of them. Okay, and that way they'll be in the same location. So right now this just looks like the rod part, and but we're in an assembly file. So what we want to do is save, and we're going to save off as our assembly drawing number. So it's S60 53. Notice that's a 2-digit number starting in 5, which means it's a sub-assembly. In the configuration management I'm using, which is McDonnell Douglas. And then it's a revision 0, T for my first initial, Frazee. We're going to hit save. And that way we don't save it as the wrong name. Now over on the left on the tree, instead of seeing features, you see the model. And if you expand this, it is all the features that go into making up that model. So you can open the model, but it's a separate file. And you can do so by right-clicking on it on the tree and use the open part file. And what will happen is you've now opened the individual part, so you can change that part and then come back to the assembly. I'm going to go ahead and close that, but you can tell by the feature tree. Okay, so we're back in assembly mode. Now we want to bring in our second component. So we're going to bring in the primary piston cap. So we go to assembly, and we're going to use this insert component command. Okay, and what that does is allows you to bring in another component. So now we're going to bring in the 111, and it's going to just kind of float around. Okay, we're going to just stick it out in space here by clicking. Now at this point, I don't know if we really need the origins, so I'm going to go ahead and hide them, because what we're going to use is assembly associations to put these together. SolidWorks calls them mates. In Fusion, they call them joints. So you can choose your poison there, but and there's different types of mates. So let's pick on the mate command, and we have our standard mates. So we have coincident. We've been talking about that. That works very much similar to sketching, but it's going to be coincident features on the models. You have parallel, same thing. Perpendicular, you can make a relationship between the two parts to make them perpendicular. Tangent, concentric. There's lock, which tends to be used for motion. So if you leave some mates, if you don't fully constrain them, you can do that on purpose. Because say you want the shaft to spin, you can do that. And there's also a host of advanced mates. So profile center, symmetric, you can do width and width, which I use a lot. There's a path mate, unilinear couplers. And then there's these mechanical mates, which are designed for animation. So you can do a cam, a slot, a hinge, a gear, a rack and pinion, screw, and universal joint. And if you put the parameters in correctly, like for the gear and the rack and pinion, you'll see the model advance at the proper ratios in an animation setting. Okay, so we're just going to start with our standard mates. That's mostly what we're going to use in this class. So these are both round parts. This round piece goes inside this round piece. Our first component is fixed in model space, so we can move this around, but the rod is fixed right now. Okay, so what I'm going to do is I'm going to do a concentric mate between the cylinder, if you pick on the surface, of the one component and the cylinder of the other. And now those are constrained so that they have to be concentric to each other. Now you can choose to check this box, and it only appears on concentric, which is lock rotation. So it means that the two parts they're concentric, but they can't spin relationship to each other. If you do that, it can spin. The assembly won't be fully constrained, but it depends on your design intent. But it's faster if you want them fixed. Like the purpose of these components, they would be fixed relative to each other once they're pressed together. This is just to select that box. Otherwise, you need to put in another relationship that locks the rotation. So it's just saving a step there. Now we can say OK. And so these two components are now concentrically related to each other, but I can move the one around because that's the only constraint it has on it. And I shouldn't be able to spin it in relationship to the rod. Alright, so let's put in our next relationship, which will freeze these two together. And if we look at our drawing, the rod end is pretty much going to end up being flush with the back side of this. So we're going to put a coincident mate between the face of the rod and the back face of the cap. And when you accept that, they should be attached flush. Okay, So now if you were to pull on this component, it shouldn't move anywhere. Now we want to double check that our distance is correct because we have a measurement on our drawing. In zone B4, it says the rods should be sticking out approximately 1 inches and 180 thousandths, plus or minus 20, or plus or minus 10. So let's use this tool. I don't know if I've shown you. It's under Evaluate, and it's called the Measure tool. Looks like a measuring tape. And it allows you to select on features and take measurements. So I'm going to pick on the plane of the back of the cap and the plane of the end of the rod. And our distance should be 1 inch, 180 thousandths, like our drawing. So that looks great. If it wasn't, then that would mean this rod needed to be adjusted where it's inserted. All right. Well, this is going to go pretty quick, so we just have one more component to bring in and assemble to this to finish the sub-assembly of the S60-53. Okay, so we're going to go back to Assembly tab, and we're going to accept the mates that we did so that our menus return. And we're going to go back to Insert Components, and we're going to select on the highest part number. Okay, and you notice the assembly icon in Windows, gives you a different icon there. And its file type is an assembly document instead of a part document. Okay, so we're going to bring in the 113. And we'll just stick it somewhere in space. Okay, as you can see on the left, the first two components are fully constrained in their mates, so that it doesn't have a negative symbol like this shell piece has. So we're going to do something similar. We're going to basically use the two same mates to mate this together. We're going to go and make a coincident mate, or I'm sorry, a concentric mate. So we're going to go off the inside cylinder, and we're going to pick the outside cylinder. And it'll try to predict which mate you want to use. So in this case, it did. We want concentric, and we're going to lock the rotation. I'm going to hit OK. All right. So they're concentrically aligned, but I can still pull on the shell and move it back and forth. And you notice there's a substantial gap in between, and that's intentional. That was designed in there to allow the solder to have space. Okay. When we braze this together. Okay. So our final mate to finish this assembly is going to be between the back face of the part and the back face of the cap. And if that's done properly, you should, see them aligned in space there. And we can accept that, and we now have our full assembly. And we're going to accept that, and over on the left, all of our assemblies are fully constrained. For this sub-assembly, I will enforce that. You need to have them fully constrained. You'll see in a couple of the others, I'm going to let them slide for specific reasons. And because we want to have motion between the parts, and it'll show that symbol of unconstrained in that sense. All right, make sure you save. It's going to ask you if any of the components changed. It may ask you if you want to save them all, and I would. And if you've done this properly, you shouldn't be able to pull the individual parts apart. They'll always be aligned. I'm going to show you how to upload these. You need to upload all 4 of these files in Canvas. So in Canvas, and make sure they're uploaded together, because I need to download them all to see your assembly. If I just have the assembly file, it's going to give an error and ask for these 3 files. So you need to keep your file structure together, upload all 4 files, and in Canvas it defaults to only uploading 1 file, but it says right below it there's a blue highlighted lettering that should say upload another file type. So let's go to Canvas. Okay, so we're here in student view, and you can choose a file. To upload, and if you want to add another file, you simply pick on add another file, and it opens another window, another file. So that way you can select your 4 files and upload them here. Okay, and you just hit submit assignment. All right, thank you for your patience, and I hope you enjoyed this video. Should have been a short and sweet one, and hope you see you on the next one. Talk to you later.